Good morning, students. We'll be starting with our chapter 1 of Unit 1, that is Cartesian coordinate. The first topic in Cartesian coordinate is the Cartesian xy plane. So, when we talk about Cartesian xy plane, how does it provide a mechanism? So, Cartesian xy plane provides a mechanism for translating pairs of related variables into a graphical format. So if you have an xy graph and their coordinates are similar, and to translate those pairs of similar values, what graphical format is being followed is called the Cartesian xy plane. The variables are normally x and y. So the normal graph values are also x and y. They are never more than that. Rather, if it's 3D, it's x, y, z. So as used to describe functions such as y is equal to 3x plus 2. So if I want to denote this on the graph, how I can do? Every value of x has a corresponding value of y. So if in a graph, if we check, if we have one value on the x plane, intersecting or corresponding that value somewhere on the y axis also there will be one value with which they can connect. So that is called as the similarity between two coordinates when they are visible on the graph. Every value of x has a corresponding value of y, which can be located on the intersecting axis as shown. So when they say that it is shown on the axis, how it is shown? So it is shown like this. See, if I have on the xy plane, that is here somewhere the value, and I have the value up on the upper side of the y, and then I have somewhere on the minus x value. So intersecting those values at a certain point is called as the Cartesian xy plane. The set of points forms a familiar straight line associated with equations of the form of y is equal to mx plus c. So wherever they intersect at that point, the equation is being formed with the help of coordinates on the x side, that is x axis, as well as the y axis. By convention, the axis for the independent variable x is horizontal and the dependent variable is y vertical. So, independent variable, that is the variable which does not has an equation related variable, its x axis, that is horizontal way, and which is the dependent variable, that is suppose I say y is equal to, that is I am giving y the value of x. So it's a dependent variable and that is being shown on the vertical side, that is on the y axis. The axis intersect at 90° at point called the origin. So every graph is 90°. So wherever it intersects is called as the origin. The first point from where it starts is called the origin. Letters x and y should be used to represent variables. So to represent the equation, the letters which are used are called as variables. At the other end of the alphabet should be substitute numbers. So the equation numbers which we have got should be the substitute numbers to calculate the value, which form an equation such as, so with all these things, the equation which is formed is y is equal to ax2 plus bx plus c. So this is the equation on which your Cartesian coordinate system works. Cartesian plane is such a simple idea that how an orthogonal coordinate system should use for graphs and coordinate system. It is the very easiest and the formulated way to put a equation on the graph. Any point P on the Cartesian plane is identified by an ordered pair of numbers x, y. So every Cartesian coordinate plane coordinate number will be denoted in bracket x, y, where x and y are called as Cartesian coordinates. So these points x and y will be determined as Cartesian coordinates of P, that is the point P where it is intersecting. Mathematical functions and geometric shapes can then be represented as list of coordinates inside a program. Yes, if you want to denote a square, a circle, a triangle, all the points where it is intersecting or the coordinate points means, suppose if I take a square has 4 corners, so the 4 coordinates altogether will be calculated. If a circle is there, only one point somewhere on the axis will be calculated because it has no point. If a triangle is there, it will have 3 coordinate points, so that will be calculated. So altogether calculation is made for shapes and geometric shapes and mathematical functions. Mathematical functions means a is equal to x square, b is equal to xy. So all these mathematical functions also can be represented on the graph. Next is function graph. Function graph here means a wide variety of functions such as y is equal to mx plus c, that is linear. Quadratic, if you see y is equal to ax2 plus bx plus c, that is quadratic equation. Y is equal to ax3 plus bx2 plus cx plus d is cubic equation. Y is equal to a sin x, trigonometric equation. So these are different types of equations which we follow in the mathematical functions, that is linear, quadratic, cubic and trigonometric. And for that, create familiar graphs that readily identify the function's origin. So depending on these equations, they create a graph through which they can be identified. That is, if I have ax square plus b, that is, it is quadratic. If I have ax cube, that is 3, that means it's cubic. If I have sin x, cos x, tan x, cot x, so that will be trigonometric equation. Linear equation means it does not has more than one variable, so that is linear equation. Linear functions are straight lines, so linear functions will be either straight lines, quadratics are parabolas, cubics have S shape, and trigonometric functions have often like a wave like structure. So to identify these equations on the function graph, if you have straight line denoting a coordinate, then it will be a linear equation. If you have quadratic equation, it will have parabolas, that is somewhere here up and down, that is called as, with the coordinates all together, that is called as parabolas. Cubic will have an S shape in a vertical format, that is called as a cubic equation. And if it is trigonometric, it will have a wave like structure, which is called as a trigonometric equation on the function graph. Such graphs are used in computer animation to control the movement of objects, lights and virtual cameras. So as they have specified, such graphs, whichever are there, are being used on your movement of your objects, lights, that is the backlights, and the virtual camera, which is moving all the time on the animation process. So as you can see, this line denotes, the curvy line denotes the diagrammatic trigonometric equation. So brightness, frames, all such things are identified. This shows an horizontal axis marks progress of time in animation frames. The vertical axis records corresponding the brightness of virtual light source. So the light source corresponding the frame, that is the actual frame in which it wants to fit. Such function forms a part of animatory user interface. So it will show you an animatory interface on which it can work and communicates in a very manner and brightness of light for every frame of animation. So every frame of animation will be altogether identified in the frame on the basis of the curve which it has. The animator can make changes to the function with the aid of interactive software tools. So this is just an example of this graph, Cartesian coordinates. It can have any number of coordinates, and the animator can change the image on all the directions of the screen depending on the brightness, light and the virtual light source which it has. Next is the geometric shapes. So there are two types of geometric shapes, 2D and 3D, that is 2-dimensional and 3-dimensional, and they have their own numerical descriptions as well. Now the shapes in geometrical identification for both, that is 2D and 3D, will be polygons, circles, arbitrary curves, mathematical functions, etc. So they can be polygons, that is more than 3 coordinates, circles, that is infinite coordinates, arbitrary curves, that is up and down curves to show the denotions of moving lights, mathematical functions, that is variable changes every time when the image moves. For the moment, though, we will only consider 2D shapes. When we consider here, we will not take 3D, we will first go with 2D. So the polygon shapes here are, a polygon is constructed from a sequence of vertices. So polygon will be calculated with the help of vertices, and for example, polygon has more than 3 vertices. So depending on how you develop a polygon, a straight line is assumed to link each pair of neighboring vertices. So if I connect one line, I need 2 more lines to connect the end point of those lines. Intermediate points on the lines are not explicitly stored. So intermediate, there is no interconnection of those points internally, but at the end points there should be some points which are connected, and there is no convention for starting of chain of vertices. So there is no certain rule that from where I should start my convention depending on that, but software will often dictate whether polygons have clockwise or anti-clockwise vertex sequence. So the software can tell you what is the starting line and what is the ending line. If the vertices in figure have been created in anti-clockwise sequence, they could be represented in a tabular form as shown. So in the tabular form also they can be shown likewise. So depends on the coordinates what are being put forth by the value or the moving picture. So this is basically the mathematic graphic of